Welcome to Session 13, Compound Inequalities. Today you will distinguish intersection and from union, or solve three-part inequalities and translate bounded real-world conditions. Watch the structure, not just the arithmetic, because each move must preserve the meaning of the problem. The visual gives us the central idea. For an and statement, retain only the overlap of the two shaded regions. For an or statement, retain both regions because either condition is sufficient. Endpoint circles still follow strict versus inclusive signs. Use this first move. Identify whether both conditions or either condition must hold. Then, for a chained inequality, apply each operation to all three parts. Worked example, solve an and statement. Solve -5 is less than 2x plus 1 is less than or equal to 9. Step 1. Subtract 1 from all parts. -6 is less than 2x is less than or equal to 8. Step 2. Divide all parts by 2. -3 is less than x is less than or equal to 4. Step 3. Graph open at -3, closed at 4, and shade between. The final answer is -3 is less than x is less than or equal to 4. Check that it satisfies the original conditions and carries the correct units. Now it is your turn. Solve 2 is less than or equal to 3x1 is less than 11. Pause, write each algebra step, and use the next 6 seconds to finish your solution. Here is the model solution. The answer is 1 is less than or equal to x is less than 4. Add 1 to all parts, then divide all parts by 3. Verify it against the exact wording before moving on. Session 13 recap. Identify whether both conditions or either condition must hold. Next, for a chained inequality, apply each operation to all three parts. Then, reverse every comparison when dividing all parts by a negative. Finally, state contextual domains such as whole numbers or non-negative values. A complete solution shows the reasoning, checks the result, and states what the answer means.